Good afternoon, everybody, and welcome to the first New Power Progress Summit organised by KHL Group and its magazines New Power Progress and Diesel Progress International. My name is Alex Tanner. I'm delighted to be your host for this afternoon's proceedings, wherever you are. I'm broadcasting live from Paris. We have more than 1,600 attendees registered for today's event, which tells you something about the demand for information on topics such as machine electrification, hybrid powertrains, and fuel cell technology. We've got 5 expert speakers who will bring us right up to date with developments. Before we start, I'll be giving you a few housekeeping notes about how the platform actually works. But before I do that, I'd like to introduce Ian Cameron, who's editor of New Power Progress and Diesel Progress International magazines, to say a few words. Over to you, Ian.
Thank you, Alex. Good day to everyone. And on behalf of KHL and Diesel Progress and Diesel Progress International, thank you for registering. Alex has just mentioned the figure that we had for registrations, 1,650. Which, for considering this is the first time we've ever had this event, is pretty amazing, I think. But thank you all for registering. It's much appreciated. Whether you're an equipment manufacturer, a dealer, or an end user, the 5 great speakers that we've got lined up today should all give you a really good insight into the business landscape at the moment and will enable you to make some informed decisions. Obviously, I'd like to thank our sponsors who are helping to make this event possible. We have silver sponsors who are Eaton, FPT, and Philips and Temro. And we have supporting sponsors, Dana, KGP Automotive Intelligence, Lawson's Recruitment, and ZF. Now, this event is a big chance for you to not only learn a lot about what the speakers are going to be saying, but it's a great chance for you to network, ask questions, just interact as much as possible. So I hope you enjoy the event, and I'll now hand back to Alex. Thank you.
Thank you very much indeed, Ian. So you will be conducting the question and answer sessions with each of the speakers. So we'll see you on the screen again very soon. Now, before I introduce the first speaker, I'd like to give you a quick summary of the program and a few words about how to use this platform. We will have 3 industry presentations followed by a short networking break, and then 2 final speakers and a roundtable discussion. All in all, we should cover that in 2 hours. At the end, because this platform will remain live, we encourage you to stay online for 45 minutes to network using the chat and video call functions. Now, a few words about the platform itself. You will be watching this on the viewing box. If you want to maximize that, then you can click on the full screen option on the bottom right of this box, or you can click the pop-out option. If you use the pop-out option, that allows you to continue to chat or network while viewing the event. For networking purposes, there's a social wall which you can use to post messages or pictures, whatever you want to say. You can contact attendees individually using chat or video call options. That includes the representatives of the sponsors. To do that, you have to go to the networking or attendee sections and search through the lists. There's also an exhibitor hub, which gives details of our sponsors, including their representatives who are live on the platform. Next to the viewing panel, there are chat, question and answer, and poll buttons. The chat button allows you to send public messages to everyone watching. And the question and answer option allows you to ask direct questions to the speakers. And we hope you'll be doing that. The questions are moderated, so please expect a few seconds delay before they actually appear. So please don't ask questions using the chat button because we won't see them. If you have a question, use the question and answer button. Now, before we move to our first speaker, we wanted to conduct a short poll of the audience. So we have you all together, so it makes sense to ask you about some important issues facing the industry today. We will have two polls today, and you will find the first one by clicking on the poll button alongside the question and answer and chat buttons. So if you could do that, you'll find that the first question is, what new power technology do you anticipate will gain commercial market acceptance most quickly? So what new power technology do you anticipate will gain commercial market acceptance more quickly? You can choose between one of the following 5 options: battery electrics, hydrogen fuel cells, hydrogen combustion engines, engine electric hybrids, or Mr. Fusion. I'll give you a few seconds to try and do that. Yes, I think that the results are very clear. They are very clear for engine electric hybrids, as you can see, going up into the lead with, in second place, more or less, joint, battery electrics, a bit like the Eurovision Song Contest. The things change all the time, but a very clear lead there for engine electric hybrids. There we are. So thank you very much. It was very interesting to have your point of view. So I think that's a very appropriate lead into our first speaker, who is Joe Bamford, who is chairman of Wrightbus, a zero-emission bus manufacturer, and also founder of Ryse Hydrogen, which is building a network of green hydrogen plants in the UK. So Joe is also the son of JCB owner Lord Bamford, and has obviously been immersed in the world of construction equipment from a very young age. So over to you, Joe.
Hello, good afternoon. I'm here to talk to you about hydrogen, which is something that I think is the energy of the future. Well, actually, the energy of the now. We have a business called Ryse Hydrogen, which we set up about 4 years ago to make clean, affordable hydrogen. People might ask, why hydrogen? Well, for me, you get mass adoption of zero emissions when it costs the same, when it does the same, but when it's as easy to fill up as the incumbent. And in reality, hydrogen is the one that most replicates human behavior. The most difficult thing to change, I think, when it gets to zero emissions are people. And if you can very simply fill up a machine, a vehicle, with gas, with a nozzle, quite similar to LPG, then I think you get mass adoption, as long as we can get it to cost the same. Now, it doesn't cost the same today, of course. We have a lot of engineering to do to get the cost base right. But hydrogen is, a fuel. You make it out of water. Well, there are other ways to make it, but I think water is probably the best way to do it. And green hydrogen is a very lovely solution to our energy needs as a world. Now, coming to zero emissions, you can look at several different solutions, but ultimately you've really got batteries and you've got hydrogen. And both of them have their own issues, and they both have their own solutions to those issues. We can work our way through them. The batteries work very nicely on a car. They do what it says on the tin. There is range anxiety, and there are some of those problems. But as you get bigger and heavier, batteries become more and more of a problem. Not only from a packaging point of view, but also from a charging point of view and from a distance traveled point of view. At the moment, we make hydrogen buses, we make diesel buses, and we also make battery buses. A diesel bus does about 300 miles on a fill-up. A hydrogen bus does 285 miles on a fill-up, and a battery bus does 110. It takes 4.5 hours to charge up, whereas a hydrogen bus takes 7 minutes to fill up. Therefore, it most replicates the behavior around buses. When you start looking at construction equipment, batteries work very nicely on smaller stuff, 1.5 ton minis up to about 10 tons. When you get above 10 tons, you start having problems with packaging and also charge times. It's quite difficult to charge vehicles on construction sites. Normally you'd use a diesel generator to do it, so therefore it slightly defeats the object of going to zero emission. Now, hydrogen can happen in a number of different solutions. There's something called a fuel cell. It was originally called a hydrogen battery. It's kind of simple. Ultimately, you have a membrane and you hit one side of the membrane with a hydrogen dot and you hit the other side of the membrane with an oxygen dot. It creates a lot of electricity, which drives the vehicle. So the vehicle's an electric machine or bus, and water is a byproduct. That is kind of a simple solution to going to zero emissions. You can also use hydrogen in combustion and combustion engines. In fact, BMW had hydrogen combustion cars running around in 1997, I think, if I'm correct. And again, that can be fully zero emission. So, you know, there are lots of solutions that are going to happen over a period of time to get to zero emissions. Construction equipment is a little earlier, so a little later to have to get to zero emission than on-highway stuff. Off-highway takes a bit more time. However, you know, all these times keep getting suppressed. So therefore you have to speed up the whole process of going to zero. So any sort of hybrid solution is an interim solution. It's okay, but you know, the interim might get less time. We've seen in Britain, it's gone, you know, all cars to go to zero emission by 2040 is now 2030. And they want to ban diesel and petrol engines. And very quickly that will happen also in construction equipment. So hydrogen, like I said, it most replicates our human behavior. We can make it out of water, and ultimately water comes out the exhaust. You can move it around, you can fill up in a similar sort of manner to using a diesel Bowser on a construction site. You know, and again, like I said, it'll do a full day's work, which I suppose is what we're trying to do. So yeah, I suppose, look, at this point in time, I'm very open to having questions and answering questions on what people feel about hydrogen and give you some benefit of my experience.
Thank you for that, Joe. It was an interesting presentation. We do have one or two questions already. One of them is, do you detect much affection and enthusiasm for hydrogen among the decision makers?
Among the decision makers as in government?
Yes, as in governments?
Yes, I mean, certainly in the UK, our Prime Minister has got a 10-point plan for building back better, and 2 of those points are around hydrogen. Europe has decided they're going to spend $500 billion over the next 10 years on developing hydrogen in the European market, not hydrogen production, but also the hydrogen supply chains of different elements of hydrogen. Because like I said, you can't do it all with batteries. Batteries don't work very well on the bigger and heavier stuff. So Europe and UK have decided that they're going to try and focus on hydrogen and have a foot into the zero emission markets while they're still going to look at batteries. You know, China's done a brilliant job on batteries and done it really brilliantly, but they now have 73% market share when it comes to batteries. So I think Europe is trying to play catch up and have one foot into zero emissions, and that foot is probably hydrogen.
Okay. Can you just give us an update on what progress you're making with developing the infrastructure through Ryse? Is it making good progress?
Yes, look, we already deliver hydrogen to buses in London, and we're making production facilities connected to new renewables. And those are being done at the moment. So we'll have full production systems in 12 months' time, but we're already delivering hydrogen today. And we already have hydrogen buses running on the roads in the UK. I also know that we've shown hydrogen combustion engines this week in JCB, and also we've shown hydrogen fuel cell and 20-ton excavators. So there's quite a lot of progress going along, and there will be more progress coming along in the future. We've got to get to net zero as quickly as possible.
Thank you. Another question. There's a question here regarding it says, do hydrogen engines run at high temperatures, and do they require thermal management solutions?
Well, yes, anytime you burn anything, if there's a combustion engine, yes, it will need thermal management. And, they do run at high temperatures, but you can deal with that. And it's, there are solutions to those things.
Yeah. There's a question here from North America. It said, what kind of timeline do you expect in North America before the hydrogen infrastructure begins to be reliable? Any thoughts on that?
Well, look, the really difficult thing is it's construction equipment's not the place to start with hydrogen because ultimately it's too disparate and there's too many different types of machines. And ultimately you have to start with something like buses where I've got volume and I've got buses going home to a depot, and therefore I can make production. Once I've made production, then the other things come on stream. I think you'll start seeing hydrogen construction equipment probably 2025 onwards. You don't see it today. What you'll see between now and 2025 is hydrogen production facilities being built up for other industries, which will then be used for the construction industry.
Yeah. And why do you think it is? What is the reason that hydrogen systems are not in focus as much, sort of, as in personal vehicles, do you think, at the moment, compared to batteries? Is there any thoughts on that?
Yeah, look, it's quite easy to plug in a few cars, and actually battery cars, do quite a nice job, and you can package your batteries inside of a car. The difficulty with hydrogen is, to get it to work on cars, you need, in the UK, there's 8,328 filling stations, and you probably need 4,000 of those overnight to be, with hydrogen nozzles. However, if you did have 4,000 with hydrogen nozzles, I don't think anyone would have battery cars because it most replicates people's behavior. One of the difficulties with batteries is not the actual prime mover, it's actually the grid and all the infrastructure and scaling up. That becomes a massive problem. And I think we'll start seeing that later on in this decade.
Yeah. When do you expect the total cost of ownership for fuel cell heavy duty equipment to be similar to diesel?
In about 2 or 3 years' time.
Yeah. Okay. That's great. Well, thanks again, Joe. It was the most interesting presentation. Thank you for your time. Back to Alex.
Okay, well, thank you very much indeed to both of you. Thank you, Joe Bamford. That was interesting. Thanks for joining us. And thank you also for sending in your questions. For our second speaker, we move on from hydrogen technology to have a look at developments in electric and hybrid powertrain systems. We're delighted, in order to cover this topic, to have with us Kimmo Rauma, who's Vice President at Danfoss Power Solutions. So, Kimmo, thank you for being with us, and it's over to you.
Thank you, and really nice to be here. And just to give you a short introduction, so my name is Kimmo Rauma, and I'm running the mobile electrification division in Danfoss, and that division is called Danfoss Eaton, just to give you a background. And already from the starting point, I apologize, my presentation will have quite a lot of technical information, so don't worry if you don't follow it fully, and if you are interested, please feel free to contact me or the editor to really learn more. But this will have a quite bunch of information, trying to deep dive as shortly as possible to the basics of the electric motors and drives and the current development there. So first part is that when we looked at highway electrification or heavy-duty electrification, there was a report done by Interactive Analysis in 21, so this year. And they start with the position that you need to remember that there's always high mix and low volume in these areas. There is no high volume like in the passenger car when you talk about heavy-duty area. And because you have the high mix and low volume, you will not be able to get the cost savings to the components through production volume scale. And what that means that the cost savings would more likely to come through the product and full system integration, which means that you really need to look your application, how to integrate the system and get the total cost of ownership to really bring the benefits. And that's really going then to the total cost of ownership as a value proposition, and not to go to the component price which comes to the scale. So you need to remember on the off-highway and heavy-duty area that there is all the time question which is also voiced out in this analysis, is that the expectation of having the on-highway or the passenger car components to off-highway or heavy-duty area and utilizing that because the costs will be so much lower in that area. But what are the difference there? That none of the heavy-duty area or the off-highway electrification has or have the powertrain laid out, which is similar, common. So if you have an integrated axle for passenger car or even for a bus or the high volume truck, you cannot use it in the excavator or probably even not in the wheel loader. So you will anyhow need to design a different ones. And when we come to the actual part that comes from the actual usage, the duty cycle demands, even when you go to truck, it's so different that actually the outcome of what kind of components and parts you should use become with a different outcome to actually get to the high efficiency powertrain and to the total cost of ownership. And this is many times forgotten and looked over that, okay, this is the best way to go is to use the lowest cost component coming from the high volume area. Because we have then the wider spread of the peak power in the heavy duty segment and the duty cycles, then the steady state is also different. And when we now look this will then start to define, okay, what kind of components and development we need to do to actually match to the demand of the heavy duty area on these duty cycles and with this differentiation on the peak power and the steady state areas. So let's start and deep dive to the electric machines. I have taken here a few of our own machines as a comparison, which the first one is used in a bus and truck applications. The second one, PMI 240, is used in the mobile off-highway applications. And then I took just a comparison out of the market, which is publicly known, which is the PMI i3 version. And all of these are around 160 kV as a power. And then you can see the relatively sizes or amounts of different materials here in the table. So first of all, if you think that the first type is surface magnet motor, you can say that, okay, there has the lowest amount of material. So you could say that that's the cheapest choice and you should go for that. And the truth is that that one has a best starting torque cube. The nominal point efficiency is relatively good. The magnet amount is lowest, but when you need the high speed area, there is no field weakening in that one. And also then the overall performance, the overall efficiency, what you see is lower than in the other two machines. And then when you look the integrated permanent magnet machines in the BMW, you can see that it has slightly higher amount of material, but still it is a different one. And then the synchronous reluctance assisted permanent magnet machine, which is using the iron reluctance to give you more peaks there, has the biggest amount of materials, but at the same time, the capabilities are different for the high spread of the duty cycle and having the highest efficiency in the area of low and medium speed area, which is the area that you're actually going to use it. So just a certain basics what you can see here. So the first one is a surface magnet motor where the magnets are on the top. The second one is an area that you have really the iron reluctance to use, and then the BMW one is also similar type of that. Then when we look at the different behaviors, you can see that there is a peak power what is different. And as told, the permanent magnet machine that is a surface mounted, of course, it has the highest peak power for the torque, and then it goes down relatively according to the positions that you can see here. And now you could easily say that, well, the surface mounted is best if I want to have the highest peak, and I don't have the need to use the high speed area, but the high torque area. Then let's look at how it looks like in the real systems. Now, here on the top right side, you have the outcome of the system with the PMI 250 and with the gearbox and with the inverter. So it looks like this as an outcome because you need to have the gearbox there to get the high speed area needed for a bus or truck. So you start to have quite much, even it has the lowest amount of actual materials in a motor. it has then, of course, the gearbox and a lot of parts coming through that. And then, of course, it also needs the highest amount of current because of the capabilities that we get through the surface-mounted magnets. Now, when we look then the PMI 240, then you have the highest area of the speed, and also you have the peak torque through the synchronous reluctance. So actually, you don't need the gearbox if you are able to utilize the system, but you easily then need at the same time a little bit more current to get all the areas there. So you might need more power electronics to support that. But the actual system, if you think about that, how many moving parts you have there, that's the most simplest one, and also can be used in quite many applications as such, and easy to assemble there, because no need of the mechanical gearboxes. Of course, there is a reduction gear as well. And then just as a comparison, how does it look like when you then do a passenger car and how you put it there? It starts to be highly integrated and quite highly complicated compared to the other two versions up there. But the first thing that it needs to be understood, there is no one solution that is good for all. That's easy starting point. The reasons that we have for different kind of machines are because the duty cycles of these are different for car to bus, truck, and to the off-highway application. And such a way, it is not possible to compare directly what kind of technology one should use for the application, but you actually need to understand the physics behind and what kind of a target you have for the total efficiency and to the complexity of the system that you want to build. Okay, let's deep dive now to the electric converters. And there, I just took our basic converter there, and where we have a capability now to build motor controllers out of it. We can use a generator controllers. We can put active front ends there. We can build microgrids, and we can build DC-DC converters. And just to show that every one of these other ones will use then passive inductive components and also capacitors there to make the filters needed for the other ones. And this is just to deep dive a little bit in that what kind of technology we would need and what the benefit of the silicon carbide will bring us. And in this particular device, we don't have active silicon carbide components. We have a silicon carbide diodes, and we will come down to the point. The silicon carbide is commonly asked from us that, okay, should I use it? It's actually now the one that everybody is speaking about, and typical question is that, okay, the efficiency is the reason that one would use it. And in Danfoss, we have a capability of vertical integration. So we actually have our own power modules and capability to produce our own power modules. So we are at the moment the only company capable of starting from the silicon up to the full system. So we really deep dive into these areas in the company. And let's start firstly on the standard silicon. So we are talking about this area here, what you can see, which is the efficiency area where it's typically used. And you can see the standard silicon, that it is about 98, 97% efficiency, what you can have. And then it drops down when we go lower in the speed which we are using. And now when we have a silicon carbide addition there, you can see that the area of 98% efficiency is larger. So we can say, yes, it is better. It is clearly better for the area, and it's also larger for the bigger efficiency area. And now one could say, okay, let's take the silicon carbide because we save in the efficiency. But you need to remember silicon carbide is more expensive because it has the carbon added to the silicon. So it's more expensive to produce. But of course, you get a little bit more efficiency extra there. If you have a 100 kilowatt system and you save 1% unit, it means that you have 1 kilowatt difference. So does it pay back in your application if you are only basing it on the efficiency difference of these two products? And should you go there? The answer is typically that no, the efficiency of the single component is not enough to justify it. You need to understand that where to use the actual part and how to utilize the benefits. And that's then when we come to the passive components. That's the actual area where the value of the silicon carbide comes out. Because we have the higher efficiency, we are capable of increasing the switching frequencies of the switches that we have there. And increasing the switching frequency will allow us to use much more smaller components in the passive side. And here is a comparison of our actual changes. So the new generation of our devices will use, and we already have the converters that use full silicon carbide active switching. So this is a comparison of the equal converter, and the left-hand side filter from the LCL filter that we use is the one that we use in a silicon-based design, and that's 8 kilohertz design. And now when we go to silicon carbide, yes, we save the 1% unit in that device as well, but if you look the size difference, when we can increase the switching frequency to 30 kilohertz, you can see that it goes from 4 kilograms almost to 1 kilogram. That's a significant size, weight, and cost savings. So now the extra money that we use to the silicon carbide compared to silicon starts to pay off. This is the reason that the silicon carbide becomes the mainstream here. Not because it has an independent efficiency difference as a inverter part, because the inverters in general are already in having a high efficiency as such. Okay, what I want to say on these ones, so to get the best system for your applications, you really need to find a partner that knows these technologies, can support you with the technologies and analyze the duty cycles of the systems to come. Okay, I'm back, as one famous movie star has been saying. So sorry for that. I have a big storm here, so it's a little bit blocking the network. But as I said, the systems are the important one, and the partner for the system is really, really important to select, to be the one who understands the electric parts and how to utilize the components and the right technologies behind it to come out with the best total cost of ownership onto the end customer. This is a key to success in this area, because there is no one technology that wins the all. That's important to remember. Okay, let's go to some of the real life cases. And as we want to understand the full application and really understand what we can do, we have a capability in Danfoss to build full machines. So we have this called application development centers in all the continents, one in US, one in Europe, and one in China. And in these ones, we build actually full machines and change them to use any of the technologies from Danfoss. And one of these is a wheel loader that we changed from hydraulic version, diesel driven, to electric driven, where we also drive the hydraulics with the electric motors. And this is the most modern, so really the brand new version coming out from the market that we get the fair comparison. And I will not go into details. You can find this machine. It's publicly known. Any customer, any partner can come and see. And when the world is allowing it, you can visit. This is in Norfolk Application Development Center, and you can even get a test drive and understand. And we show openly all the technologies, what are used there, and how it is built. But what is important to understand, and when you select correctly the technology, the actual power utilization, the energy consumption of the system, it's really coming down. And also that it's already possible to build the systems where you can operate full day of duty cycles of this kind of machines. And just to also show the outcome of the system, this is not an area that is actually really straightforward. You really need to understand the system, understand what is the application duty cycle, put the full system together, and also get the chargers and connections to the energy storages all together. And what we went through to understand what kind of motor technologies you want to use there and what kind of technologies inside the power converters you have there really will bring out that what is the total cost of it, and also what is the outcome in a total cost of ownership when you are using it. So let's go to the next one. I just wanted to add here one also of our customer cases, which is a really interesting one. So this is Spearing mobile cranes. They have been now 1 year out with this application where you have a machine which is driven with electrics. It also can use a hybrid, so it has a diesel engine. And here we come out with the solution that it needs a 2-speed gearbox. And then it has all the applications that you have here. So when it comes to the construction side, you can use it fully electrically. So because these are typically used in the city centers, they are really wanting to have the opportunity to have a silent operation mode for the full time that it's there. It's now really running, and the customers are just enjoying it, and it's working perfectly. And then the few things that we needed to understand here, that how fast you actually want to go and drive with the electric mode. And you can find here that the outcome was actually that it doesn't really need a higher speed, 80 kilometers per hour to go there with the full electric mode, because it had made the system quite much more expensive to make it full range. When we are going and moving from city to other, or the construction site to another construction site, we can drive in a hybrid mode. And when we are at the site, it's totally fine if we can operate and drive it inside 30 kilometers, 50 kilometers per hour. No problem at all. And then, of course, we need to operate the wind system throughout the whole day that it's there. So this is one kind of application where the market is really moving, and more or less, if you see that what kind of machines the customers today buy, they really change now to the electric version of this company. And this is a really, really nice example, and also one of the quite complicated ones, because you have all the things that one can think. You have all the applications, you have the charging, you have the batteries, you have the capabilities of hybrid-driven system and the electric-driven system. So you really need to have a partner that can support you with the full system. And I'm really proud of this machine that is built. Okay, when you want to see more, when you want to play out with these systems, there is a e-configurator, and you can find it on the Danfoss Hydrogen webpage, and it's free of use to everyone. And there is some examples. This, of course, doesn't go to really too deep that you could get a really full ready answers out of it, but at least it gives you a guidelining what kind of drivetrain, what kind of gearboxes you could use and should use when you build your application. It asks questions from you about your application, and then it gives you a proposal how you could build it. There is also really nice real-life examples that are shown that how it's built, what are the benefits out of it, and how it's actually the power is going around. So please feel free to go there and play with these tools. And it is just made to everyone to learn and know about electrification, and that it can be done today, and there is a possibility to move the world to the more cleaner one at the moment, and we don't need to wait for 2030. We can actually move now. So thank you for listening. That was a quite amount of information, and I understand that it might be a little bit overwhelming with all the technical details, but I'm happy to hear any questions from you. And please, let's go to the questions.
That was great. Thanks, Kimmo. It was a really useful and interesting presentation. I'm sure everyone in the audience got a lot out of that. We do have some questions. One of the main questions we have, I'll read it out. It says, it sounds like the specification process is or will become a lot more complicated for off-highway machines. Does Danfoss see a way to simplify this, or will each electric machine application require a separate, more involved development process?
Yes, that's a really nice question, and typically we go through the machine together with the customer, and it's more about the end use of the machine to make it good rather than the technology, because the technology is serving us whatever means we need to have it, and we have the tools already now to make it clear that how it is utilized and how it is what kind of technologies we use. So we can help with that. And yes, it's still more complicated than just to make a traction system to the passenger car. That's for sure. And there is a lot more different kind of variations of this when you start to do it. But if you have a machine, just feel free to contact, and we will help you to find out the different options, and then you at least have a starting point to go forward.
Okay, thanks. Another question: do you anticipate? Sorry, it was. Question one, do you have dual inverters in your portfolio, so one inverter can handle two motors?
Yeah, we can have, but we don't do the dual inverters so that we have one mechanical box for two inverters, because this is again let's say optimization that comes as there might be a need for it, but then what sizes you would put together, what is the volume to do that, and we will do those if the volumes in the market shows that, okay, this is the actual power range where the dual inverters would fit to the outcome, and until that we believe that having a clear one strong portfolio, putting the volumes together from all of our three business lines, marine, on highway and off highway, will support the best to all the customers at the moment.
Thank you. Do you anticipate that electric motors might replace some of the machine functions currently handled by hydraulic pumps and motor systems?
Yes, that's of course the case, and one of the interesting thing to be a leader of Electron is that we are positioned in the Danfoss Power Solutions, which is probably the biggest hydraulic company in the world after we finished the acquisition of the Eaton hydraulics. Now it is probably the biggest hydraulic company, and at the time that Electron is winning, my colleagues are losing something. So that's the target, that we will eat that area to Electron, and our prospect is that also whatever the customer needs, we want to be there to serve regardless of the technology. So yes, the electric motors will replace some of the hydraulics.
Thank you. It's been asked, how do you calculate the total cost of ownership of a battery hybrid system in commercial vehicles, and what would be the commonly accepted variables?
Well, the basic calculation starts, of course, of the energy use. That's the easiest one to show that the efficiency is so much better that the actual payback comes from the energy that you are saving throughout the lifetime and throughout the operation. Then the second thing is the maintenance. That's a little bit more harder, because then it comes to actually what kind of machine it is and what are the other components. But what I use as an easy example is that how many moving parts typical passenger car diesel-driven has. It's about 30,000 moving parts. And when you have an electric passenger car, you have the number is less than 1,000 moving parts. And only thing you maintenance are the moving parts. So for fact, the maintenance is going down. How much, then it depends of the application and the relation between the moving parts that are actually there. But these are the two areas that we look together with each customer, and then we can quite let's say we have a methods that we get a quite good answers to any applications out there that what the numbers will be in when we realize the machines. We have already over 100 different types of machines which we have electrified in the real life. So we know quite well that how different duty cycles will behave.
Okay, and it's been asked, can you say what battery technology are you using for construction equipment?
Well, we use all of them, depending again of the application. So we use titanate, lithium titanate ones for the ones that we have power peaks, but we still want to drive the electrically certain time. Then when we have a long terms of operation with the steady mode and with the average power, then lithium iron phosphate is probably now one of the technologies that is used mostly. And then we use a lot of supercapacitors also when we have just a huge peak of powers utilized, like in a stone crusher, when the peak power is just 10 seconds, then actually the supercapacitors are there, really nice option as well to cut the peak power and such a way improve the efficiency of the machines. So I could say that we have used them all. Then we also have done it with the fuel cells as a hydrogen driven and also with the synthetic fuels one. So we don't care where the energy is coming from. We just design then the powertrain system at the moment.
That's excellent. The last question came off. If you can advise, it's asked what kind of two-speed gearbox do you use on mobile cranes? Power shift, or with load interruption?
Well, it depends. We have used both of them, and then we have also developed together with some gearbox manufacturers some new type of those. So we have used both of them. I think that the most common one is that when you really need to take the load off and then continue. That's sometimes as an engineer a little bit pity because you would like to do it with the load on, but the cost is then of course a driving factor when you come out with this. But there is different types, and we work with the gearbox manufacturers to make the best one out of it. And I think that in the future, the next generations of the gearbox will be tuned more to the fact that electric motors can be much more faster controlled, and then the gearbox can be much more simplified, and also it's more easier to do the shifting without needing the clutches in there at all.
That's great. Thanks again, Kimmo. It was an outstanding presentation. Thank you very much.
Thank you. It was a pleasure. Thank you.
Thank you. And back to Alex.
Okay, well, thank you to both of you, Ian and Kimmo, and obviously for asking your questions too. It's time now for our third speaker before we move on to a networking break, and we'll be focusing on transmissions for electric vehicles. We're delighted to have with us Julie Marshhouse, who is Engineering Manager for e-mobility at Eaton Core. And please remember to keep those questions coming in for Julie. Thanks so much for being with us here today. Where are you calling us from today?
I am actually located in Wisconsin. So I like to tell people I worked from home before COVID made working from home what everybody did. So just over 10 years from a home office, and 4 years prior to that in an Eaton office. So happy to be here today, Alex.
Perfect. Okay, well, we'll hear your presentation. I'm sure there's going to be some questions for you too. So over to you.
Okay, absolutely. So we're going to talk about transmission technology. So really Eaton's role in enabling electrification, considerations of, hey, you've decided you might want an electric vehicle. What do you need to consider? And then really, why are we saying that transmissions are recommended? So Eaton started our e-mobility segment of Eaton 3 years ago. So we're just up on our 3-year anniversary. And what e-mobility did is it brought together segments of Eaton that were previously industrial sector, previously within our electrical sector, and brought together all of those things into the e-mobility group. This group is really experienced with vehicle dynamics due to a long history in truck transmissions, axles, a lot of the different things that Eaton's been involved in over the years. And then it pulled in our electrical segment. So some of you may not know, but Eaton has a huge product line within electrical. Almost any commercial building that you walk in today is probably going to have a power panel that says Eaton on it, and it's going to be Eaton's electric circuit protection. So just like Eaton's been protecting high voltage in our offices and our homes, we're bringing that expertise into this e-mobility space for vehicles. When we look at what part of the vehicle that Eaton's really looking to specialize in with the e-mobility group, we're really looking at power electronics. How do we manage the electrical power on the vehicle? And then power distribution. So just like those circuit panels in your house or your office, we're focused on how do we distribute that high voltage power safely within the vehicle and reliably. And so how do we know, how do we have to keep our high voltage separate from our low voltage. We keep everything working together. In addition, we're focused on power systems, which is really what my group is doing, managing that power in the vehicle to get from our tractive device out to our wheels, and then also focused on gearing. The areas that Eaton is not focused in on the bottom, so really HVAC and thermal management, there's lots of people that do that space really well. That's not an area that we're focused on. Energy storage, when we talk about the batteries themselves, or hydrogen, as our speaker talked about earlier, we're not focused on that type of storage. And then additionally, just like my friend from Danfoss, Kimmo, was speaking about a little while ago, where Danfoss is focusing on traction motors, that is not a space where Eaton is currently focused on. So let's talk a little bit more about where Eaton thinks electric commercial vehicles make sense, right? This is the question we all ask ourselves. We've been in this industry for a while. Some of us are new, but where do commercial vehicles and electric, where do those paths really cross? So what we're looking at is pickup and delivery. So think of like the city delivery, beverage distributors, regional haul, those folks that start and stop from the same distribution center every day. Buses, we've absolutely seen electric buses take off in other regions. We know that electric is expanding in Europe and the United States. So really any type of bus market, it could be a city transit, shuttle bus, school bus, the tourist buses. Our favorite type of bus, some of us, is that bus you get on at the airport to get to your rental car location. Someday we'll be able to travel again and we'll get to go do those. But those are the types of buses that they've got these set routes. They always go back to the same place. Regional haul is the other area that I mentioned, kind of goes along with pickup and delivery. We're also seeing more of an interest in the municipal market. So when we talk about street sweepers and water sprayers and city dumps, again, those day trip type vehicles, or they go out for time and then they always come back and have a chance to recharge. Port drayage and yard tractors on the bottom of the screen, those two really go together. We're seeing a really big emphasis on the ports, especially with what's going on in California. There's a lot of initiatives to try to get the diesel vehicles out of those regions and have cleaner air and cleaner environment. And really with the things that are going on today in the electric market, we've got the ability to go do port drayage and yard tractors. So the next thing we're going to look at is that, okay, I've told you where I think we need electric vehicles. So let's talk a little bit more about what type of drivetrain we think that these vehicles might use. So just to level set us, some of you are going to say, oh my gosh, I can't believe this is in there. This is so basic, but it really just helps get us all talking about the same thing. So the first type of electric propulsion system we're going to talk about is direct drive. So this is honestly the most basic. This is a golf cart. This is the simplest way we can do an electric vehicle. We have the electric motor directly tied to the rear axle or to the wheels and propelling the vehicle. Then we go to a central drive transmission architecture. It's a very familiar layout. This is how our vehicles have been set up for years. We have a power source. We've just taken out that engine and we've put in an electric motor instead. And that power source is putting power to a transmission, which goes out to its standard drive shaft and a rear axle. The third technology is an e-axle. The E-axle concept is that we have the electric motor and the gearbox are somehow integrated into the drive axle. Sometimes that may include the traction inverter, other times it may not. So those are kind of the three different primary architectures that people are using today on commercial vehicles. So then the next question that I get a lot is, well, how do I know which one I need? So we've kind of started a yes-no flow chart. So I hope that this helps everybody out with how do I know what I want? How do I know what I need? So the first question is, are you looking at light duty, medium duty, or heavy duty? If you've got a light duty vehicle, you're going to go direct to direct drive. It doesn't make sense for most light duty vehicles. They're more similar to passenger cars because they're a lighter load. It's going to be very rare that you would have to have a geared solution for a light duty. When we look at the medium duty market space, it could be any of the solutions, but the next question we have to ask ourselves is my medium duty operating on flat ground or is it hilly? Am I in San Francisco? Am I in Brazil? Am I in some of these more hilly regions? In that case, we're going to jump up to the top question. And if you're flat, if you're in an area that's very flat, you don't have a lot of hills, and you're at an airport operation perhaps, in that case, direct drive is probably going to be the best solution. But then if we've got our medium duty on hills or we have any heavy duty, the next question we have to ask ourselves is cost sensitivity. Am I cost sensitive? Well, then if I've got cost sensitivity, I likely want to go look at a central drive. If I can handle the higher costs and I want to go out and get the latest, greatest thing that somebody's invented, then an e-axle is likely a good solution. And I know there's lots of argument and comparison, and you guys probably have 100 questions for me, but this is kind of our view right now about how you would make the determination. But then I know we've had a lot of discussion about off-road. So I'm going to throw in another slide and say, hey, wait a minute, you need a PTO, and you need a PTO to go run something that's really high power where I'm going to use most of my torque from my electric motor or that I would have used my diesel engine to provide. If I need a PTO and I want to use PTOs that are readily available on the market today, then that's going to jump heavy duty and medium duty both to saying, hey, central drive architecture is probably your best solution. If you don't have a PTO, gets us back up to our cost sensitivity question we had on the previous slide. So I hope this gives us all just a little bit of an idea about, hey, how would I start making this decision? The next thing I want to talk about is gears. And so a lot of us are familiar with our conventional engine space where we have 12 gears, 10 gears, 18 gears. And I'm doing an EV transmission right now for the heavy duty space. It uses 4. So why do I need fewer gears? So the answer comes in when we look at a torque curve between an engine and an electric motor. So the orange line here in the middle, this is a typical engine torque curve. My peak torque is around 1400 RPM in this example. But if I look at my electric motor torque curve, I've got peak and continuous on here. So just remember the only difference between peak and continuous, peak's the maximum my motor can put out, and continuous is what my motor can put out every day, all the time, no issues. We don't have to worry about overheating. So that's my torque curves. But I always have peak torque starting really at 0 speed out to a high RPM, in this particular example, around 2300 RPM. And the other thing to know that's different between diesel engines and electric motors is that in my diesel engine, my peak efficiency is around the middle of my peak torque range. On electric motors, my peak efficiency is at my highest RPM that motor can run to. And this drives some different technology and decision points that we have in electric vehicles that we didn't have in conventional engines. So this gets us to a shift chart. So this is just an example of a heavy duty EV drivetrain shift chart. For those of you that are familiar with these, awesome. Anybody that's not, across our x-axis, we have vehicle speed. And on our y-axis, we have motor speed. Motor speed would have at one point been your engine speed that you see on your TAC in your vehicle. So what we're looking at here is we're looking at two different rear axle ratios. So if I went in my heavy duty EV vehicle and I went with a conventional rear axle ratio at 2.25, you guys have heard of that one a lot, then what happens is I don't even get into fourth gear until I'm well over 100 miles per hour. And so what the electric vehicles are doing for us is, because I'm trying to keep my maximum efficiency at top speed, I need to keep that motor operating in the higher RPM bands. So I'm going to go to a higher rear axle ratio, even in a heavy duty, and I'm going to go up and I'm going to pick a 4.0 rear axle ratio. And so no longer am I saying, hey, I want to do my highest rear axle ratio because I got to keep my engine speed low. I want a high rear axle ratio to keep my engine speed high. So this is just a quick overview of the new heavy duty EV transmission that Eaton's working on. This is a full aluminum housing transmission. As we talked about, this is a 4-speed transmission. We're trying to do a common motor adapter. So this would work with, you know, anybody's motor that might be out on the market today, with potentially a couple changes on their side. And we're also going with helical gears to make sure that we've got as quiet of a transmission as we can in these electric vehicles. Just a quick overview of what this heavy duty transmission can do. Maximum end speed is 5,000 RPM, 2,600 Newton meter torque capacity. Trying to keep it light. We're at 195 kilograms, and ratios from 5.87 up to a direct of 1:1. And this is really targeting that class 7 and 8 market. So Eaton's got a whole bunch of different transmissions in our portfolio. This is absolutely available out on Eaton's website. But really the two primary transmissions that we're focused on today is our medium duty EV 4-speed and then the new heavy duty EV 4-speed. And then what's next, right? So it's a transmission, central drive, you know, future state. We're looking for ISO 26262. We're looking at cybersecurity. We're looking at UDS, so the Universal Diagnostic Services, and OTAP, so over-the-air programming. So Eaton's doing what we're doing now, plus we're also looking to the future and saying, hey, what other technology do we need to be in our product so we're ready when our customers are? And that's what I had to share with you today. I would love to hear any questions from the audience.
That's great. Thanks, Julie. It's a really interesting presentation. Not surprisingly, we do have a few questions, if I can put some of them to you. One question is, from a power transmission side, is there any difference between a battery electric vehicle and a fuel cell vehicle?
There really isn't. So when we talk about Eaton and our XEV portfolio, it's what does the X mean to you? It could be a fuel cell, could be a battery electric, could be a range extended electric, but we're really looking in that drivetrain. That's electric motor direct to the transmission.
Okay, and another person asks, what sort of maintenance or maintenance cycles are required for vehicles with the 3 different types of vehicle architectures? And they ask how much additional training of maintenance technicians is needed.
That is a great question. And I'm going to go on a little bit of a limb to answer part of that. So direct drive, I would say that would probably have the least amount of maintenance, but you are dealing with that electric motor and high voltage. So we want to make sure that anybody working on a electric or hybrid electric vehicle has the correct high voltage safety training. That's very, very important. We need to make sure that all of our people are safe every day. So I would assume that the conventional vehicle likely is going to be more standard to what our technicians have done in the past in terms of maintenance on that vehicle and on the transmission. In e-axle, because it is a newer technology, and I think the electric motors and those rear axles are a little bit more integrated, that one is probably the highest degree of change in the service strategies.
And someone asks, wouldn't an independent wheel motor system eliminate the need for a transmission? For example, the new Rivian truck?
I think the Rivian truck, forgive me, I'm not super familiar with that one. But I think as we go to the higher GVWs, as we get to our standard 40,000 GVW, that heavier weight is going to do better with a central drive or a conventional rear axle, e-axle, versus some of the wheel motors. The wheel motors to me are a really interesting technology, but I've taken this electric motor and I've got it on my unsprung mass of my wheel, and I'm long-term makes me a bit nervous.
And when do you believe electrification will replace diesels 100%?
Oh, that is an amazing question. Everybody would love to have the answer to that, and we'd go reinvest all of our stocks, right? I think that we're going to end up with electrification pretty soon for a lot of industries, which is really that slide I talked about earlier about where do we think that we're going to see electric vehicles first. I think that the longest time to go and try to change the space is going to be in our more rural, remote areas. I think that those rural, remote areas are going to stay with diesel engines longer, and it's going to take longer to get electrification to those. So if we think parts of Alaska, parts of Australia, parts of possibly China, I think those are going to take longer.
That's excellent. Julie, thank you very much for your presentation today. Thank you. Back to Alex.
Thank you, it was very nice. Thank you for having me.
Thank you so much for being with us, for that presentation and for answering all the questions. We're now going to take a short break. Let's say it's 7 or 8 minutes or so to give you all a chance to stretch your legs a bit, maybe have a tea or coffee. But could you please also spend some of the time completing the audience survey, which is on the platform. Survey, as you will see, is one of the options on the left of the platform. And also feel free, if you like, to have a quick network with other delegates or simply just watch the video. So it's 6 minutes past 5 here in Paris, whatever the time is with you. Let's say we'll meet at 15 past the hour. So see you in about 9 or 8 minutes. See you then. So everybody, welcome back. I hope you had a nice little pause. We're ready to start again. Before I introduce our next speaker, I think it's time to have another poll. It's always interesting to find out the tendencies and to see what you think. Once again, you will see the questions and possible answers by clicking on the poll button that's next to question and answer and chat buttons. So please, if you could click on that now to see the question, which is about investment in new power technology. Let me talk you through it so you can concentrate on which answer you're going to give. How much of an investment has your company made in new power technologies to date? Would you say we're spending more now on new power than on conventional technologies? We're spending about the same on both new and existing technologies. We will start investing more when market adoption appears to be closer. We've been looking at alternatives, but not done much yet. And we'll let everybody else go first. So let's see what you're saying. There we are. We have the results, which seem to be much more of a fine balance than what we were having before, with a slight advantage for, I know it's just changing as I'm speaking. We're spending more on new power, was taking the lead, but it's like the same with we will start investing more when market adoption appears to be closer. Or we've been looking at alternatives, but not done much yet. It's that the very fact that they're changing all the time, I think, is an interesting comment in itself. But if we seem to be settling, we'll start investing more when market adoption appears to be closer, seems to be going into a slight lead. Anyway, interesting. Time to move on with the program. Our full speaker, delighted to have him, is Jonathan Wood, who's Vice President of New Power Engineering at Cummins. Jonathan's presentation is entitled "The Case for Heavy Duty Fuel Cell Vehicles and the Policies Required to Support the Transition." Jonathan, I think you're in Huddersfield. Hello.
Hello, good afternoon, good morning, good evening, wherever you are in the world. It's very nice to be here with you and in the New Power Progress Summit.
And if I can just remind people to send in their questions, because you'll be answering questions just like other speakers before. So please hit the question button before. Over to you.
Okay, so anyway, good morning, good afternoon, good evening, wherever you are in the world. It's nice to be here with you. I'm going to talk today about heavy-duty fuel cells and more specifically, the policies that I think we need to support the transition as we move to clean technology, zero-emission vehicles. So before we jump into that, maybe I'll just give an overview of Cummins. So we were founded in 1919 as the Cummins Engine Company. The corporation was based out of Columbus, Indiana, and one of the very first diesel engine manufacturers. In 2001, we changed our name to Cummins Inc., but we're still headquartered out of Columbus, Indiana. That still remains our technical center and headquarters, but we've become much more geographically distributed as we've grown over the last 102 years. We're a global power leader. We design, manufacture, and distribute diesel and gas engines and powertrain-related components such as filtration, after-treatment, fuel systems, control systems, and of course, power generation, batteries, and electrified power systems, some of which I'll talk a little more about as we go through the presentation. We sell our products to OEMs, distributors, dealers worldwide, and as you can see, we've got over 8,000 distributors globally. We continue our investment on critical technologies and products, and I was interested to hear the last survey we had on how we're thinking about where we're spending in terms of investment on future technologies. You'll see on the stats there that we made 1.3 million engines in 2020, which is quite significant, and that's just us. And later on, I'll talk a little bit about our new power segment and how many we're making in that area, and you'll see quite a stark difference and shows the start of the transition that we have to new power. So a key question of this is, of course, we've made our name for the last 100 years in diesel engines. So why the interest in hydrogen fuel cells? So we've always had a very deep commitment to bringing the right technology at the right time to enable our customers' success. We are a commercial vehicle provider, as in power providing for commercial vehicles, whether they be on highway, off highway. We also do stationary power generation and various industrial equipment. We spend a lot of time working with OEMs, fleet owners, municipalities to really understand the jobs that they're trying to do. Our product has to enable their success. And so we built a good understanding of the different applications, the duty cycles, and being able to tailor a solution to their needs has been an important part of our business. For a long time, the answer to that has actually been diesel. It's been diesel or natural gas. And that's been very much dominant in the commercial vehicle market, the commercial application market. But as we look forward, we're seeing a much more diverse set of solutions that are going to be required. And hydrogen will be part of that answer. As we look to empower customers with real world products that's going to meet their needs and how they're going to serve their own customers in that future. So pivoting to the new power segment, this is the most recent segment to the Cummins group. And within the new power segment, we really have three product groups. Firstly, the electrified power, which focuses on the design and manufacture of electrified power technologies, which includes batteries, battery electric powertrains, components. And to date, our focus has been very much in applying those technologies to applications where the total cost of ownership, the value proposition is most attractive. So that is in applications on highways such as transit bus, school bus, some medium duty truck and walk-in vans. And we have applications across the world that are growing in those areas. And the off-highway space, we do have applications in the construction equipment, terminal tractor market, and also in material handling. And we're seeing these as the first adopters within the commercial environment to start using the battery technology. In the fuel cell and hydrogen technologies, we've got fuel cells and electrolyzers. And in that group, we design, manufacture, and install industrial and commercial hydrogen generation, fuel cells, and megawatt scale energy storage solutions. The applications developed include both PEM and alkaline hydrogen generators for industrial purposes and fueling stations, and hydrogen fuel cells for electric vehicles, such as urban transit buses, commercial fleets, utility vehicles, and power supply systems. Hydrogen and fuel cell technologies are based out of our headquarters, which is in Mississauga, Canada, after our acquisition of Hydrogenics back in 2019. But we also have facilities in Milton Keynes in the UK, Gladbeck in Germany, Erville, Belgium, and also in China. Most recently, particularly in our electrolyzer space, we've recently been involved in a 20 megawatt PEM electrolyzer system to generate green hydrogen in Canada, which is the largest currently in the world. And most recently just signed a direction with Iberdrola in Spain, and also committed to install production plant for the production of green hydrogen in Spain, which will initially have production capacity of 500 megawatts a year and will be scalable to more than 1 gigawatt per year. So we really see the growth of the hydrogen electrolyzer to develop the infrastructure to support fuel cells as we roll out into the market for commercial vehicles. Just a few stats on Cummins Hydrogen and where we are today. With our acquisition of Hydrogenics, we've acquired nearly 70 years of fuel cell and hydrogen experience with that acquisition. We to date made 2,000 fuel cell installations, 60 hydrogen fueling stations, and 500 electrolyzer installations. All of that, we're very proud of that progress. But when you compare that to what I showed earlier in the slides are 1.3 million engines per year. You can see we have a long way to go when we're right at the front end of this industry. So this is a real growth opportunity. It's a real opportunity as we transition from the diesel and gas solutions to both hydrogen and battery electric vehicle. And this is an exciting time to be at the start of this. So as we think about fuel cells in the heavy duty vehicles specifically, the existing freight and public transport network continues to grow everywhere. And the heavy duty fuel cell vehicles are a very significant contributor to greenhouse gas. Looking at some of the recent data, specifically in Europe, heavy duty road freight transport accounts for around about 26% of road transport CO2 emissions. The European Green Deal has stated that the expectation is that the transport sector needs to cut greenhouse gas emissions by 90% by 2050. And that's based on a 1990 baseline. So as we look to this, as we think about the solution to this decarbonisation challenge, it's clear that this is going to be a blend of technical solutions. For over 20 years, I've spent my career in diesel improvements, meeting regulations on criteria pollutants such as NOx from diesel, and also greenhouse gas, CO2. Diesel has come a tremendously long way and is going to continue to be part of the future solution, certainly in the short to medium term. But if we're really going to achieve these fundamental challenges of climate change and carbon neutrality, then zero emission vehicle solutions are clearly needed to address this. Both battery electric vehicles and fuel cell powertrains, which are combined with batteries, are going to play a key role in this future freight transportation solutions. Both do offer advantages and challenges, and both are still quite early on in their technology maturity curves, but are progressing very quickly and moving fast. OEMs are today offering reliable and efficient ZEVs to the market, and these are going to continue to increase with the coming years. We think fuel cells offer advantages in long distance freight duty cycles because they provide opportunities for fast refueling and route flexibility and high vehicle utilization. We think they're well suited for heavy loads and long haul with quick refueling, and of course they are zero emission. Whatever the solution portfolio looks like, the choice and adoption rate is going to be very dominated by the total cost of ownership. This is going to be critical, particularly in commercial vehicle space where operators purchase a vehicle or to complete a job. And of course, cost and total cost of ownership is going to be paramount. Infrastructure and regulation will also shape the adoption of these different solutions. TCO is very much influenced by a number of factors, and that's going to impact the rate at which fuel cell reaches TCO parity with diesel. The initial cost of purchase, fuel costs, product life expectations, subsidies and incentives, even the electricity and the fuel origin is going to play into the TCO and at what rate that achieves parity with diesel. Different duty cycles, applications will clearly get there sooner and will perhaps favor more a battery solution, and some will favor more a hydrogen. Whilst we as tier one suppliers and OEMs can influence some of these factors in development and R&D, there's a real need, we think, for clear, ambitious policies to support the attainment of these ambitious greenhouse gas targets and drive us to more cost-effective technology solutions that are most importantly adopted by users. So if we think about the policies required for the transition, I really break these out into three areas: infrastructure, development, and deployment. We are pleased to see that so many governments act over the past year to produce hydrogen strategies. This includes the European Union, France, Spain, Belgium, and Germany. And I really hope that as we develop these hydrogen strategies across more regions and in more countries, the strategies focus on three areas of support, which are the infrastructure development and deployment. In the infrastructure space, it's needed to ensure our systems can support the adoption of hydrogen and fuel cell technology economy-wide. Government investment in infrastructure sends a very strong signal to industry that this transition is happening and creates more certainty for investment. A focused drive is needed to increase the investment in hydrogen fueling stations suitable for our heavy-duty vehicles, so we have good geographic coverage and addresses the use cases of both regional and long-haul driving, where we think fuel cells are going to be a really important technology. We really need to see a build-out of the network of fueling sites to enable wide-scale application of hydrogen heavy-duty trucks with compressed hydrogen, either 300, 350 or 700 bar application to match the tank pressures we currently have. We think policy should also support both industry and government research and development in these new technologies. R&D is absolutely still needed as to optimize fueling and storage systems for hydrogen, fuel cell efficiency, the durability expectations. A diesel engine has had nearly 100 years of development, and now we can trust it will deliver 20,000, 25,000 hours worth of operation. We have to see that same performance coming from these new zero emission applications. And of course, we've got manufacturing capability needed to achieve the wide scale adoption that we need to really achieve the greenhouse gas targets that I talked about earlier on as part of our ambition. R&D policies that support partnerships across the supply chain and academia with fundamental research into ZEV technology is really welcome, and we continue to support that. It's good to see Horizon Europe as an example of the good progress, and the APC in the UK, the Advanced Propulsion Centre in the UK, funding low carbon technologies is most welcome, and it helps industry form partnerships with suppliers and academia to further develop the capability and create jobs. Policy deployment that encourages deployment through direct funding, investment initiatives, and purchase incentives will help us close the gap between hydrogen and fuel cell technology to more traditional power sources. It will help us close that TCO gap to diesel and promote the adoption of ZEV. I think this will allow us industry to move more quickly to scale up and lower the cost. So financial frameworks, including incentives that support the transport operators to adjust their operations to zero emission trucking, would also be welcome and encouraged to enable this further adoption of a hydrogen environment. So finally, I'll say the regulations, I think, need to be ambitious. In Europe, we'll see the Fit for 55 package coming out, which will be launched in July, which will be a series of new legislation from the EU that tries to operationalize the commitments of the EU on climate change in the new EU Green Deal. Ahead of the package, governments at all levels must partner with industry to develop the right infrastructure, investments and R&D innovations to enable us to adopt and embrace the new zero emission vehicle technologies for the future. I want to thank you for listening. Appreciate your time, and hope I'll hopefully take any questions if there is any.
Thank you for that, John. That was a very good and interesting presentation. Thank you very much for that. Not surprisingly, it has prompted quite a few questions. And there's one question in particular that's been asked several times. What are the limiting factors for considering fuel cells for construction equipment?
The limiting factors, well, I think as you think about fuel cell application, I think the things we need to be thinking about are firstly, duty cycle, the transit nature of the duty cycle, and where that and the operation of that as it fits within the fuel cell duty cycle. I think the other thing is tanking and storage of the hydrogen. One of the big challenges with hydrogen is storage and tanking of that within the vehicle. So those are the two key areas I would say are the most important, but we are clearly looking at construction as an option for fuel cell.
Okay, thank you. And another popular question is, how long do you think it will be before hydrogen fuel cells are a significant portion of the commercial vehicle market? Or will it only really take off when required by regulation?
It's another really good question, and it's one we continue to tussle with. As we think about the adoption, we're starting to see small-scale adoption now. A lot will depend, honestly, on that TCO calculation that I talked about. Being able to obtain a green, low-cost hydrogen as a fuel source is going to be critical for the TCO model, because the cost of hydrogen is significantly higher than diesel at this moment in time. And of course, one of the big costs of heavy-duty trucking is the fuel costs. So actually getting low-cost hydrogen, a hydrogen infrastructure, becomes really important for that adoption. I think we'll start to see wider scale adoption of fuel cells probably 2030 onwards. Between 2030 and 2040 will be the key time where we start to see probably larger scale adoption.
Thank you. And another question is, what sort of investment is required to produce 20 megawatts of blue hydrogen?
An investment in terms of dollars?
Yeah. I think that's what the questioner is asking.
It's a good question. I'll be honest with you. I wouldn't want to give a number out. I think it somewhat depends on where you install it, the energy available, and the infrastructure around you. So I don't think I'd want to give one number here, to be honest, on that one.
Okay. And what's your perspective on the pros and cons between hydrogen used in a combustion engine or fuel cells?
That's a great question. We are looking at both. We're definitely exploring both. There's internal combustion engine manufacturers as well as fuel cells, and we are looking at both. And there are totally pros and cons for both of them. One thing I'll say is the fuel cell has the advantage in peak efficiency for operation. We've seen that, and we're getting distinct advantages of that. So that's something that clearly plays into heavy duty, because efficiency, fuel usage when the fuel is high cost, becomes really important. On the flip side, the internal combustion engine has the ability to use less pure hydrogen. A fuel cell requires very high purity rates of hydrogen. An internal combustion engine can live with a little different. And so it is very much depending on the application, the usage, the range required will play into internal combustion engine versus fuel cell, but there's extensive work going on both of those technologies.
Okay, well, we haven't got time for one more question, if that's all right. Jonathan, approximately what share of your 2,000 fuel cell installations are mobile applications?
I would be a little bit estimating here, but I would say fuel cell, I would say about 60%, something like that.
60% on mobile applications.
Yeah.
That's great, Jonathan. Thank you very much for that presentation. Much appreciated. And now back to Alex.
Thank you very much indeed. Very interesting questions. Thank you for having asked those questions. It's now time to move on to our fifth and final speaker today. We're delighted to have with us Thilo Huber, who's the head of ZF's Construction Machinery Systems product line. Thilo's presentation is about intelligent systems solutions for zero emission, 100% electric drivelines. Thilo, herzlich willkommen. Sie sind in Passau, you're in Passau in Germany, I think. Thilo, are you there? I think we...
Yeah, I'm there.
Ah, fantastic.
Yeah,
good.
Thank you.
You're in Passau, I think. So we lost you for a bit, but please go ahead. I think we now have you back again. Thilo.
Okay. Thank you very much. Greetings to all of you. I'm very happy to have the opportunity to present to you CF's view on the electrification of construction machinery drivelines. 100% electric, intelligent system solutions for zero emission drivetrains. The presentation will include a brief review of our system architecture, the modular product platforms necessary to cover all major applications, as well as examples of existing product offerings. But first, so sorry for that. I would like to start with a brief introduction of the industrial division. Within the CF group, the activities off the road are combined in this division. That includes all different kinds of applications, from wind turbines, rail, marine, helicopter applications, special drivelines, etc. Also the off-highway business unit serving construction, machinery, as well as material handling is part of that division. Being part of the CF group, we are benefiting from the innovation and technologies developed for passenger cars and commercial vehicles, especially today with the current developments in electrification, driver assistance, and vehicle motion control. This is a great asset for the product offerings into our market. From the very beginning, CF's product for construction machinery systems have been drivers for innovation and technology. The most current innovations had focused to improve efficiency and performance. They resulted in efficiency package for our proven ergo power, the power shift transmission, and new concepts as the C-Power, a hydrostatic mechanical power split CVT transmission. Looking forward, we are now adding electrified drivetrains to our product portfolio. The acceptance, respectively the demand for electrified drivetrains, is increasing. Even there is so far no legislative pressure on CO2 emissions for off-highway. This is different to automotive and commercial vehicles, where legislation is a significant driver. For off-highway, we see as key drivers for the electrification local regulations as demand for zero emission projects or zero emission construction sites, work in urban centers where noise and emission matters, but also the increasing sensitivity on sustainability in our societies. And with that, the need to execute and even accelerate more ambitious climate action plans. These trends are basically valid across the world, but happening in different speeds. Based on our view, the path to electrification for construction machinery is therefore not a disruption, but a further diversification of technologies. And that means that different driveline solutions will coexist. So if you take a look on our product offering, we will add a new technology and in consequence also new products to our transmission and axles control system units we have so far, we offer so far to the market. This will create multiple challenges. For example, we have to manage the increasing complexity with different technologies on a vehicle and a subsystem level. We have to realize commercial viable solutions in order to achieve a competitive total cost of ownership. We've heard that several times during the sessions. That is key for acceptance of that technology. And in addition, it would be beneficial for the overall product offering to reuse subsystems, components, but also functions and control strategies to manage the level of new content. And by that, to have a shorter time to market, as well as to ensure robust and reliability solutions. So the question is, what is the right solution? And when we asked this question, we started a comprehensive study in regards looking at all different technology solutions. We modeled a large number of systems with traction drives and working hydraulics for our target application and ran detailed analysis on a set of multiple criteria. So the baseline had always been our current products, the power shift transmission, the power shift transmission with torque converter lockup. These are the two first bars, or the hydrostatic mechanical power shift power split CVT, the green bar. And in the following, I will just refer to a comparison of the energy demand from the wheel to the tank as the one criteria or the key differentiator for the assessment of the single concepts. The baseline shows already that there is a significant saving potential with the CVT in energy consumption. But if we now move forward, one of the key questions and first question we asked ourselves was, what kind of contribution could a hybrid be? Hybrids are considered to be a potential solution for many applications. So we looked at that right away. And what we found was that parallel or serial hybrid architectures can reduce the energy demand. However, the fuel consumption reduction potential is rather small compared to the additional system complexity required. So we are looking for about 10% if you just look at the power shift torque converter lockup system, or additional 5% if we make a hybrid solution based on a CVT. The advantages of optimized operating points of the engine or the hydraulic pumps had partly been offset by these multiple energy conversions from mechanical to electric to mechanical. And with that, the benefits are as we show them here for that analysis. With that poor cost-benefit ratio, we also question if the TCO for a hybrid solution for our target application is really sufficient. And from our analysis and conclusion, we do not see hybrids as a viable solution when moving towards electrification. So at the end, we selected the full electric system, and we see here on the numbers on the energy demand, we analyzed a 36% energy demand compared to the 100%, which is represented by a standard power shift transmission. And beside that significant potential in reduction of consumption, it's also the only solution which does fulfill the requirements for zero emission. And that was the reason that we concentrated or will concentrate on this solution. With the same models, we also looked at the different driveline configuration, and we had seen examples on that in the sessions before. Our conclusion was that for the construction machinery, the central drive is the preferred solution. That means only one electromechanical system in the vehicle. Due to the specific performance requirements of construction machinery, a distributed system would have very similar power requirements. We have to have 100% of the torque at the front or the rear axle. So a distributed system would have the same power requirements as the central drive, and consequently higher system cost because we have to have a second motor, second inverter, etc. Also, we need in any case mechanical transmissions to realize the performance of the vehicle, either for max traction when we are in breakout or in working conditions, but also for maximum vehicle speed. So we need transmission concepts to be optimized to create the best balance between performance, efficiency, component sizing, and system integration. And for example, for bigger machine, we for sure see also in the future the need for multi-gear transmissions to have an optimized system. So again, we consider the central drives for the overall good efficiency, the 100% torque distribution to the axle where needed, well-proven drivetrain concepts, and the synergies with conventional vehicle designs and drivetrain topologies. So our road to Vision Zero means zero emission clearly starts here at the left side. We excluded the hybrid solution. We are driven by zero emissions to support the focus on the environment. We are focused to have drop-in solutions, to use existing vehicle architectures to have really the opportunity to have an optional solution while maintaining the conventional drives. We rely on modular platforms with a high degree of reuse, which are scalable and flexible. We for sure would like to reuse the tools, the functions we have developed, the control strategies from past application, and with that be ready for launching our electrified drivelines. Baseline for that is the application know-how and system competence we do have, but that's also what we have learned during that analysis. It's not only a component focus we need to have. We have to focus on the complete system, on the complete vehicle in order to optimize an electrified drivetrain. So if you look on a product lineup, we do have we have electrified solutions up to 210 kilowatts in production, respectively on the way. You see here we started in 2019 with an electrified mixer drive for concrete mixer. We have launched last year the electrified drives for compact equipment, compact wheel loader, other small equipment. We are in the process now to move it to the next power range, mid-size units up to 100 kilowatt, and our midterm target is to introduce electrified drivetrain, for example, medium wheel loaders up to 20 ton until end of 24. If you look at the platform necessary in order to cover that applications, it's several different platforms which are scalable in different power ranges. We serve different voltage levels. We have, and that is just an example, there's not one solution which fits all. So we have different concepts. We are coming from air-cooled for the smaller vehicles, engines, to liquid-cooled. We have ASM motors, PSM motors, transmission 1-speed, 2-speed, 3-speed. We have remote-mounted EPDOs and integrated PDOs. So we have a complete platform where we can build the adequate and the right solution for the different applications. So, as mentioned, a complete product family up to 210 kilowatt, a modular product platforms which are scalable. We achieve the same performances as the conventional drives. The solutions are drop-in, so interchangeable with a basic vehicle layout. And we do have an electronic drive control with a sophisticated torque control strategy and efficient power management for the traction drive and the working hydraulics. And we now just go through some of the solutions already presented, and that is the mixer drive, conventional, electrified. The electrified motor solution has the same performance data as the conventional one. It shares the same interface to the vehicle. We just see here in the light gray this additional e-motor and an additional gear ratio we need in order to set up to this application. And very similar on the compact wheel loader standard, the conventional drive line, the electrified one using the same or basically the same axles with the integrated transmission drawbox and the attached motor, the remote mode EPDO. solution. And we have there a product range which support 4 to 8 ton vehicles with different scaled motors, voltages from 48 to 650 volt, and power ranges up to 40 kilowatts. And I think the main focus here on this compact wheel loader was really to get the maximum out of a 48 volt system that is a 20 kilowatt continuous power, 40 kilowatt, 36 kilowatt peak, which really from our point of view is best in class for that applications. And the next product we are just in the process to prepare and launch is an electrified driveline for wheeled excavator. We see the conventional versus the electrified solution. Again, it's a modular platform. Here we use a PSM e-motor. We have a 2-speed power shift transmission with which can be remote mount or direct mount to the axle, an integrated park brake. We have a disconnect so that we are able to support applications as the wheeled excavator, but also others like a backhoe loader, telehandler, which are operating in that power range. So that are the activities focused on our vision zero, in that case, zero emissions for the electrification, and also targeted to support and to provide support for a sustainable productivity. Thanks very much.
Thank you, Thilo. That was another excellent presentation. We do have some questions, but I'm conscious that time is against us a little bit, Thilo. So if we can keep it fairly brief. The question that we've received most is that do you think ZF's OEM customers agree about hybrids not being a viable solution? And what do you say to a customer who is nervous about going all electric with his equipment?
Good. I'll start with the second one. For us, it's not all electric. I think it's not disruptive. It's a diversification. So we still have all the other technologies in the portfolio, and we keep on developing them. And when we see hybrids and the benefit a hybrid has, I would say, okay, we have solutions, conventional solutions, which basically have the same amount or the same potential, a very similar potential of energy saving available. I just prefer to the CVT transmission. And therefore, that's our statement, the complexity and the system complexity of a hybrid would not be necessary.
Okay, and people also ask, are the solutions presented for construction equipment the same for agriculture?
No, in agriculture, I think the focus is rather to provide with a transmission a source for electric power, and so it still would remain for a period of time with a combustion engine, with a transmission which has an integrated generator providing power to attachment and implements.
Okay, people also ask for some usage, for some cases such as agricultural applications, fully electric doesn't have the uptime needed. Would hybrid solutions not be more viable in these cases, or is the cost to benefits ratio not feasible at this stage?
Yeah, we see let me say, it's a trip over a very long period of time. So electrification will start with the compact equipment, but we really see now medium-sized equipment, large equipment with tool shift running time, let me say, with fuel consumptions, 500 liters per shift. That will definitely be something which takes a longer time until electrification is a feasible solution.
Yeah, and is a fuel cell applicable in existing diesel and oil-based internal combustion transportation truck engines? And if so, can you give an estimate for this conversion in trucks?
From my point, yes. Yeah.
Yes. And can you give an estimate for the conversion in trucks?
I think it's at the end of the decade.
Right. Okay. Okay, Thilo. Well, thank you very much for your help, and that was a really great presentation. So before I hand back to Alex, that was the last of our speakers today. Alex will have some interesting and useful information, but I'd just like to thank all of the speakers and thank our sponsors, who are Eaton, FPT, Philips and Temro, Dana, KGP, Automotive Intelligence, Lawson's Recruitment, and ZF. I'd like to thank you in the audience as well. You've come up with some great questions. I'd just like to say thank you, and I'll now hand you back to Alex.
Thank you very much indeed, Ian. Just a few words for me to tell you that a recording of today's event, if you want to see anything again, or if you couldn't watch the whole event, will be available to view on this platform very soon. So you'll be able to rewatch particular sessions or view the PowerPoint presentations. One word, please fill in the survey. It's always very interesting to have your feedback so that we can make other events even better. I also want to give you a date for your diary. On the 26th of October, we will be holding our third Diesel Progress Summit and Awards, and that'll be organized by Diesel Progress magazines. And that will actually be a physical event, back to meeting again, and it'll take place in Chicago. If I could also encourage you to enter the awards, you might win if your company has accomplished some achievements over the past year. I'm sure that's the case. Then this is your chance to tell everybody about it. So you can find out more at dieselprogresssummit.com, including information on how to actually enter your company for the awards. And if I can remind you also, if you're interested in information on new power technologies, then you can always visit our website at newpowerprogress.com. If I could also remind you that you are now invited to stay on this platform for the next 45 minutes so that you can network with fellow attendees. You can also send chat messages or even make video calls with other delegates. And this platform will be remaining live for the rest of the evening and indeed for the following days. Well, I very much enjoyed hosting the event today. Thank you to Ian, too, who's done most of the hard work. And on behalf of KHL, New Power Progress and Diesel Progress International, thank you very much for watching us. Have a great evening and goodbye.